In this section, we're going to be given the graphs of some non-traditional looking functions, and we're just going to go ahead and use the transformations that are given. So um, the instructions tell us that given the graph of f, we're going to plot the below graph. Okay, um, so first of all, we have this point, -4, -2, and we have this point, -2, 0, and we have other points on this function. And these are important because they're going to help us to be able to have those baselines for the function. Now, we look at this, and this tells us the transformations. There's two of them, one of which is we are going to transform the function left 1 unit, and then we're also going to transform the function down 1 unit, okay, just because we have that -1 on the outside. And so all we're going to do is we're just going to move each of the points left 1, down 1. So this point right here, -4, 2, is just going to become -5, -3. Right? Or if we're on our graph, we're right here as best as we can with this, okay? And then we have -2 zeros, that's going to be -3, -1. And then we have 0, 2, so that's going to be -1, 1, right? And that completes like the line, the increasing portion of this, right? So it's going to go up, up, up. Now we have the point 2, 2, so we move that left 1 and down 1. So left 1 is going to be 1, and down 1 is going to be another 1, so we get 1, 1, and that's the constant part of this function, right? And then finally we have the point um, 4, 0. So we're going to have 3, -1, which is right about here. And this is what our transformed function should look like, all right? And also it looks like, oh, okay, that was just another line in there from my underline. Okay, I was just making sure that that wasn't going to keep going forever, all right? So that's how we can try to transform a graph just by moving the points around of a non-traditional looking function, or maybe something that's not in our family of functions that we defined earlier. Another example, the exact same graph, but this time we have a little bit different transformation. Okay, so we have the negative on the outside, and we have a -2 and a +1. So the -2 means we're going to transform this to the right 2 units. The +1 means we're going to move it up 1 unit. Negative on the outside means we are going to reflect in the x-axis. But since we're moving it up 1, right, really what we're going to be doing is reflecting it in the line y equals 1. Okay, so when we do this reflection, all right, so, and I'll show you what that means. So basically what we're doing is we're taking this line y equals 1, and we're flipping everything over that line. All right, that wasn't a good drawing of y equals 1, but right here would be a better line. All right, so this up 1 is going to help us to determine where the function really is being reflected. All right, and what I'm going to do is I'm going to draw that line. Let me draw that in green so that way we know where it is as best as I can here. All right, so this is going to be the axis with which we reflect the points over. All right, and I'll show you what that means in a few moments once we do this. Okay, so first of all, let's just go ahead and plot the first point, and then we'll reflect it over. And we'll do that in blue. Okay, so we're going to move to the right 2. So we're going to move it right 2, and then we're going to move it up 1. Right? So what that becomes is that becomes the point -2, -1. So if I plot the point -2, -1, right, we get the point right about here. Okay. Now notice from that line that we just drew, it's 2 units away. So what we would do to reflect that point is we would draw it 2 units away, right? And that's what we mean by reflecting in this line, y equals 1, okay? So all you're going to do is you're just going to make sure that when you're done plotting the point, that that point is equidistant vertically from the point that you plotted without the vertical or without that reflection, okay? So another point that we had, let me keep that one in there. So we had this point right here. Oh, I think it was 3, -2, or -2, 3. All right, so it was -2, 3 right here. Okay. So another point we have is negative 2, 0. All right, so remember, we're going to move to the right 2, so that just becomes 0, and then up 1. So this should become the point right here. Okay, so it becomes here at the point 0, 1. Right. Now, since it falls directly on that axis, we don't reflect it at all. Okay. Next one we have is 0, 2. So we move it to the right 2, and then we move it up 1. So it looks like that we have this point that's going to be 2, 3. Okay, so we move 2 and then up 3. But remember, we're reflecting it in the axis. So we're actually just going to move it. It's going to be 2 units distance from this axis. So when we plot the point in the reflected, it should be 2 units reflected. Okay, so, and then I'm going to get rid of this. And I can go ahead and just draw this line segment now. Right? So far, that's what our reflection looks like. Now we still have a couple more points to take care of with this. So we have to take care of 2, 2. Let me erase some of this stuff so that way we know where we are with this. And so we're going to move right 2 up 1. So now we have the point 4, 3. And again, what we're doing is we're reflecting that in the axis, and that's going to be right here. So that's this part, and it should be right on that line. So it seems like I have a trouble drawing that one. Oop. Let's see if I can undo that. Oop, that's a rotation. That doesn't help. Okay, I'll just draw that line again. So here is our line. That's our reflection line. And then we have this, and that's going to be this guy right here. All right. And then finally, what we need to do is we need to plot that final point, right? And the final point is going to be this 4, 0. So again, we move right 2 and then up 1. So it looks like we're going to have the point 6, 1. Okay, so we move 6, 1. It's right on the axis. There's no needed reason to reflect it. Okay, and so that's what our reflected function looks like. Okay, and hopefully you can see that it retains the original shape because it's a non-rigid transformation. Okay, or excuse me, it's a rigid transformation because it keeps the shape. We've just flipped it over. Okay, so remember, flipping it over means that you're reflecting it in the x-axis. Okay, all right, let's see one more example of this. And this time we just have the negative on the inside, and then we have positive 3 and positive 4. So it might be helpful for you to pause the video at this point, try it for yourself, and then see whether or not you're able to do it um, based on what I get. Okay, so first of all, our 3 reflections. Okay, we have a positive 3 on the inside. That means we're going to move left 3. We have a positive 4 on the outside. That means we're going to move up 4. And then finally, the negative on the inside means we're going to reflect in the y-axis. However, and then remember, the y-axis is this line right here, or x equals 0. All right, if I was to keep drawing it, it would look like this. Okay. However, we're moving it left 3. So in reality, the line that we're trying to reflect over is not going to be the x-axis in this case after the reflection. It's going to be this line right here, x equals -3. I'm sorry, I keep drawing these poorly. It's difficult to draw on the computer screen sometimes. All right, so we're going to get this line right here. Okay, and I'll keep drawing that because we're going to have to move up and down a lot with this. Okay, so let's go ahead now and transform the points. Okay, so we take our first point, all right, which is going to be -4, 2. We're going to move it left 3. So let's go 1, 2, 3, which is off the screen. That's fine. That's -7. And then we're going to move it up 4. And when we move it up 4, it becomes 2. All right, so we have the point -7 and then +2, right, which is right here. And notice that that point is going to be 1, 2, 3, 4 units away. So we're going to move 1, 2, 3, 4 units away. And so this would be the reflected point, right? And I'm going to get rid of these little dots, right? So our next point that we have is going to be this -2, 0. So we move left 3 to -5. up 1, so we have negative 5, 1. Notice that it is 2 units away, all right? Or negative 5, 1, excuse me. When I draw this, it should be up 4. All right, so it should be negative 5 and then up 4. 1, 2, 3, 4. So we should have negative 5, positive 4, which is right here, right? And notice that it's 2 units away, so we're going to move 2 units to the right, and we're going to be right here, okay? The last point that we have before we start the constant part is 0, 2. So we're going to move it left 3 and then up 4. So moving it left 3 is going to give us a negative 3, and then up 4 is going to give us a 6. All right, so we should have the point negative 3, 6. And notice it falls directly on the axis that we're reflecting over. And so that's going to be that increasing line segment. Now, the other points that we have are going to be this 2, 2. So we're going to move it left 3. All right, so left 3 is going to give us a negative 1. And then up 3 is going to put us at, or up 4 is going to put us at 6. Okay, so we have a negative, we're going to be at the point, oh, sorry, negative 1, 6. All right, so we're going to be at this point, negative 1. And it's going to be up 6. So we're going to be right here. Um, so again, left 3 and up 6. All right. But remember, we have to reflect that. It's 2 units away, so it's over here. All right, when we reflect it. All right. And so that's going to be this constant part. Right. And then finally, for the last point, 4, 0. Okay. Again, we move left 3. That's going to be at 1, up 4. It's going to be at 4. So we have the point 1, 4. This is right here. Notice that point is 1, 2, 3, 4, 5 units away from the axis. 1, 2, 3, 4, 5 is over here. All right. And that's going to be, let me check that again just to make sure it looks like a little bit off. All right, so left 3 is going to be 1 and then up 4. So we're at 1, comma 4. And we're 1, 2, 3, 4 units away. 1, 2, 3, 4. Okay, it should be this point right here. Sorry about that. I counted incorrectly. All right. And so it looked like it wasn't a little bit off. And so that should be our final point right there. Okay. And again, notice that the function is just transformed and flipped over, but it still holds the exact same shape that it initially had. All right. So those are our reflections and also our transformations in this section. So hopefully this helps you understand the reflections, both if I'm giving you the shape of the function, but not necessarily like, a specific parent function, but also how to transform those parent functions given just a few basic transformations.